Hello everyone, today we will be discussing solution of oblique triangles. In trigonometry, we will not be just dealing right triangle. What if we have a triangle that involves angles that are not 90 degrees? This may be smaller or larger depending upon the situation. In such cases, we are involving oblique triangle, a triangle that is not a right triangle. The measures of the three sides and the three angles of a triangle can be found if at least one side and any other two measures are known. This is how we solve oblique triangles. We have case 1, if one side and two angles are known, or that is SAA stands for side angle angle, or ASA stands for angle side angle. Case 2, what if two sides and one angle not included between the two sides are known, that is SSA. This case may lead to more than one triangle. Case 3, if two sides and the angle included between the two sides are known, or that is the SAS. And what if three sides are known, or that is the SSS. So we will be using sine law in solving an oblique triangle. But we have to derive first sine law. For example, you are given any triangle, either acute or obtuse. There is our acute triangle ABC. And here is our obtuse triangle ABC. Okay, let H be the length here of the perpendicular from vertex B to side AC. And then C here is the hypotenuse of the right triangle ABD, that's C. And A here is the hypotenuse of right triangle BDC. Okay, two triangles with same height. Okay, so here is the triangle. So in triangle ADB, that is ADB, there, sine A is opposite over hypotenuse, so that is H over C. And looking for H, we can have is equal to C sine A. And the other triangle, so we have here in triangle BDC, okay, sine C here is H over A, or H is equal to A sine C. But we are talking about same height, okay? So we can just equate H is equal to H. That becomes A sine C equals C sine A. These are the value of 2H here. So a little of algebra, we can have A over sine A is equal to C sine C. Similarly, we can have this A over sine A is equal to B over sine B, and B over sine B is equal to C over sine C. That is actually our sine law. That is in any triangle ABC with sides A, B, and C, where you have A over sine A is equal to B over sine B is equal to C over sine C. Okay, let us use that sine law in solving this triangle, an SAA triangle. So we are given a side and two angles A and C. We are supposed to solve oblique triangle ABC with this given. Okay, when you try to solve a triangle, there are 6 parts, the 3 angles and the 3 sides. So you're given three three measurements, so we will be looking for another three, that is angle B and sides C and B. Among the unknown variables, there is the triangle. We will be looking first for angle B. Using the theorem that internal angles in a triangle measures 180 degrees, that becomes now A plus B plus C is 180. And looking for angle B, that is 180 less 32 less 82. Then acute angle B measures 66 degrees. Okay, so we're now ready to solve for another unknown part, that is side C. So as you can see, you have A over sine A, which is 43 and 32. Both measures are given. We have C that we're looking for, and angle C is also given, that is 82. In an equation like this, you only have to have one unknown variable, and that is side C. So a little of algebra there, you can have side C is equal to A sine C over sine A. Substituting the value of A, that is 43, so the value of angle C is 82, and the value of angle A is 32. Then we can have side C is approximately 80.35 centimeters. And the last unknown part there of the triangle is side B. So again, we will be using A over sine A equals B over sine B. A over sine A, both measures here are given, so we're looking for this. A little of transposition, that B is equal to A sine B over sine A. So substituting the value of side A and angle B and angle A. So now side B is approximately equal to 74.13 centimeters. There you go. We were able to solve oblique triangle ABC. 6 parts now are known. Let us have another example, the ASA triangle. Solve the oblique triangle ABC with angle A equals 63 degrees, angle B is equal to 49 degrees, side C is equal to 78 meters. So another 3 unknown parts. We have angle C, sides A and B. So again, we have that triangle there. So among the 3, we can solve for angle C first. So using the theorem again, A plus B plus C is equal to 180 degrees there. Substituting the values of A and B, that becomes C is equal to 180 less 63 less 49 degrees. Angle C measures 68 degrees. So from there, we can now look for side A. So A over sine A equals C over sine C. And then here, A is equal to, substituting the values, we have 78 and 63 for angle A, and angle C is 68. So compute that. That side A is approximately 74.96 meters. And the last unknown part of the triangle is side B. So that is B over sine B equals C over sine C. Just make sure that if you're using any of the sine law there, so you only have one variable unknown. So substitute it there. B is equal to C sine B over sine C. Substitute the values. That side B is approximately 63.49 meters. There we were able to solve that oblique triangle ABC since 6 parts are known already. What if we will apply that to problems? So we have this problem. John wishes to measure the distance across the big river. He determines that angle C is 112 degrees, angle A is 31 degrees, and side B is equal to 348 meters. We're looking to solve for the distance across the river, and that is side A. So we have this figure. So we were able to label with the known values, and we're looking for the distance to cross the river, and that is side A. So when you were able to label that now, make sure that you have a side and an angle opposite, which are both given. So let's try to look at this. We have 31, that side is unknown. So that is not the pair we were looking for. So we have angle B and side B. But then we still do not know B. But we can get B using the theorem A plus B plus C equals 180. So looking for B, we are now able to get the value of B, which is 37 degrees. That will be the combination that we will be using. So that is there, B over sine B. We're looking for A, that is A over sine A is equal to B over sine B. So getting the side A, which is equal to B sine A over side B. So substitute the values. We have side B, which is 348, angle A is 31, and angle B is 37. So the value approximately of that distance to cross the river is 297.82 feet. There. And we have this ambiguous case of sine law. That is case 2, wherein side-side angle are given. Okay. In this ambiguous case, we're given two sides and an angle opposite to one of the sides. If the lengths of the two sides and the angle opposite one of them are given, then 0, 1, or 2 such triangles may exist. There. And if angle A is acute, there are 4 possible outcomes. There. How many triangles? There are none if this happens. Sine B is greater than 1, where the height is greater than A but is less than B. There. So side A is too short. So no triangle is formed. Number of triangles, we can have one triangle if sine B is equal to 1. Okay, where A is equal to H. And H should be less than B. There. One triangle is formed. We also have one triangle when sine beta is what? That is greater than 0 but is less than 1. And side A is greater or equal to B. There is the figure. And it could also be possible to have two triangles when if sine B is greater than 0 but is less than 1, where A is greater than H but is less than B. There. So you have two possible triangles. Okay, if A is obtuse, there are two possible outcomes. There. So you have no triangle is formed again if that side A is too short. When would that happen? If sine B is greater or equal to 1 and A is less than or equal to B. Okay? Kasi supposedly this one, angle A, which is obtuse, and you have a shorter side, when you have the most bigger angle, you should have the longest side opposite to that angle. So this one, we have one triangle is formed. Okay, when would that happen? If sine B is greater than 0 but is less than 1, such that A is greater than B. There. So A should be greater than that side. Okay? So let us now have this example. Solving case 2, that is the ambiguous case. In this case, we're not able to solve a triangle. So the triangle does not exist. Solve triangle ABC with angle B is equal to 55 degrees, side B is equal to 10 meters, and A is 25 meters. So solving the triangle, we're supposed to look for the three unknown parts of the triangle. So we have this figure. Okay. Okay. So we have a partner. You are given side B and angle B. Okay, you are given side A, so we will be able to look for angle A. So we have to use A over sine A equals to B over sine B. So looking for angle A, that is transposing it, we have sine A is equal to A times sine B over B. Substituting the value of A, which is 25, and angle B, which is 55 degrees, and side B, which is 10 meters. Okay, using your calculator, you were able to get sine A is equal to 2.05. Okay, sine A is greater than 1 here, and that is impossible. So therefore, if you're going to use your calculator, it will just display error since no triangle exists. Okay, so let us have this example. In this case, we are now solving two triangles. So solve triangle ABC with angle A, which is equal to 65 degrees, side A is 32 feet, and side B is 34 feet. Solving the other three unknown parts of that triangle. So this is the triangle. We were able to label this. And we will be getting first angle B. It's here. Okay, so how are we going supposed to do that? It's here. Okay, angle B, that is the opposite side of side B, and we have angle A and we have side A. So from there, we have a pair of an angle and opposite side. We can look for angle B. So using the sine law, B over sine B equals A over sine A. We're looking for angle B, that is, we transpose it, that is equal to B sine A over A. Substituting the value of B, which is 34, and angle A is 65, side A is 32. Using your calculator, when you're looking for an angle, you're supposed to press inverse sine parenthesis 34 sine 65 degrees over 32. And that will display what? Okay, 74.4 degrees. And we also have another angle, which is 180 less 74.4, which is 105.6 degrees. Okay, there are two angles between 0 and 180 degrees, such that this is the value of your sine B. So in this case, we have two angles for angle B. Since we have two angles for angle B, we'll be forming two triangles then. So first we have the triangle AB sub 1 and C sub 1. Okay. In this case, we'll be finding both C, angle C, and side C. Okay, our first value of angle B is 74.4. Okay, that is the acute angle. So it's here. So we were able to label that, and angle C sub 1 is equal to 180 less 65 less 74.4, and angle C1 is equal to 40.6 degrees. Okay, from there, if we know already angle C, we can find for the opposite side, that is side C sub 1. Okay, here. So again, C sub 1 over sine C sub 1 equals A over sine A. And looking for side C sub 1, substitute the values. You were able to look for sine C sub 1, which is approximately 22.98 feet. How about the other triangle? We're now using B sub 2, which is 105.6 degrees. So we can look for angle C sub 2 and side C sub 2. There is the triangle. So we can look for C sub 2. Again, using that theorem, three internal angles in a triangle is equal to 180. Okay, so C sub 2 is 9.4 degrees. There. And we are now ready to look for side C sub 2. So C sub 2 over sine C sub 2 is A over sine A. Substituting the formulas here, the values in the formula. So we have side C sub 2 is approximately 5.77 feet. There you go. Well, how about if we have one triangle, such that an oblique triangle with A is 40 degrees and side A is 12 meters and C is 9 meters. So looking for the other unknown parts, here is the triangle. So here we have angle A on opposite side, which is 12. Okay, here is C, and that is the opposite side. Okay, that is 9 meters. So we have a pair, an angle, and the side opposite to that. So we will now be able to look for the unknown, that is angle C. So C sine C equals A over sine A. Looking for angle A, we have to transpose and have this. And there you go. You substitute the values of C, side C, angle A, and side A. So again, looking for angle, you press inverse sine, parenthesis 9 sine 40 over 12, parenthesis. So angle C is, there you go. Angle C sub 1 is 28.8 degrees. Again, there are two angles between 0 and 180 degrees such that sine C is this value. Since side C here is 9 meters, that is less than side A, which is 12. We can conclude that angle C is less than also angle A. Okay, thus the other side of angle C, the other measure is 151 degrees. But we can only use C sub 1 since that is only the value less than A. Okay, so C sub 2, which is equal to 151.2 degrees, is not possible. Kasi that would become what? Bigger than A. So solving for the triangle, okay, that becomes there. That is the figure. And again, we can now solve for angle B, which is approximately 111.2 degrees. Okay, and looking for side B, same. Okay, we will be using the sine law, substitute the values, and there, side B is approximately 17.41 meters. Okay, derivation of cosine law. Here is an oblique triangle shown. There. Okay. There is the derivation. Take a look at those. There. So this is now our cosine law. In any triangle with sides A, B, and C, you have the three sides. That is A squared is equals to B squared plus C squared minus 2BC cosine A. And we have B squared equals A squared plus C squared minus 2AC cosine B. What have you noticed here? If you have B and C here, that would be also 2BC. If you have A and C known, you have AC here. And A and B, that becomes AB here. And the angle here is the opposite of the unknown side. There, that's B, so that's side B. Angle C, and that is side C. That's for you to memorize the law. What about if we're not looking for the sides, we're looking for the angle? A little of algebra, we're able to derive this. Cosine A is equal to B squared plus C squared minus A squared over 2BC. Again, see, you have Okay, B and C here, that's the denominator also, B and C. You have A and C here, that's 2AC. And you have A and B, that's 2AB as the denominator. That's for you to easily memorize the cosine law. Okay, we can now use the cosine law in solving this SAS triangle. So solve the object triangle ABC with angle equals 38 degrees, B is 8 meters, and side C is 11 meters. So solving the three unknown parts, side A, angle B, and angle C. Here is our triangle. So substituting here the values. Okay, so you see you have two sides given and an included angle. We can look for the opposite side of the given angle. So using the cosine law, you can now substitute the values in the formula, and the opposite side is approximately 6.81 meters. So now we are ready to solve for angle B there. Okay, cosine B is equal to A squared plus C squared minus B squared over 2AC. Substituting the values, we can now get angle B inverse cosine. Make sure you have a parenthesis here. Try to calculate this, and angle B is equal to 46.4 degrees. Actually, you can use here the sine law already. If you were able to solve for A, if you don't like to use cosine law, you can use the sine law instead. Okay? And since two angles are known, you can use the theorem that A plus B plus C equals 180, and that angle C is approximately 95.6 degrees. There you go. Is this true? We will verify our values there. So since the smallest side is side A is less than B, and B is less than C. It should be that A is less than B, and B is less than C. So is that true? 38 degrees is less than 46.4, and 46.4 is actually less than 95.6. Yes, and our values are possible and true. Let us have another example. You're given an SSS triangle. Solve the object triangle with A is equal to 29 feet, B is 35 feet, and C is equal to 41 feet. So this is an SSS triangle, so three sides are given. You will be looking for the three angles. There is our triangle. We're able to label that. And you choose any of the angle. So I've chosen here to look for angle C first. So using the cosine law, it's here, and substitute the value. Again, using your calculator, you have to press inverse cosine and these values enclosed with parentheses. Okay, you will get then C is approximately 79.1 degrees. So here, since you already have one known angle, I use another cosine law looking for B, but actually you can use sine law. You will just get the same answer, and that is angle B is approximately 56.9 degrees. Okay, since two angles are known, you can now use the theorem to look for the remaining angle, which is angle A. There, and A is approximately 44 degrees. Okay, we have this example in a problem. So a surveyor wishes to find the distance between two inaccessible points A and B on opposite sides of a lake. While standing at point C, she finds that side A is 410 meters, side B is 245 meters, and angle ACB measures 120 degrees. Find the distance from A to B in nearest that is supposed to be rounded off to meters. There is a figure. and we're able to label that. So we will be looking the distance from A to there, the distance from A to B. Okay, and that is actually side C. That is the side opposite angle C. Okay, there. Using that cosine law and substituting the values. There you go. So that side is approximately 573 meters. That ends our lesson for today. I hope you learned a lot and you're now ready for the exercises. Thank you for watching.